Okay, I get a signal that we are live, so I hope I'm clearly audible. Mahesh, can you confirm that?
Yes.
Okay. Good morning, everyone. We're very excited to launch this series of webinars. So we're basically planning, PUG is planning uh, a sequence of webinars over the coming weeks, and the schedule will be out soon. Uh, do follow the PUG Twitter handle, Facebook pages or LinkedIn, whatever your choice of social media is, to stay updated. Um, first of all, I would like to thank Mahesh, Vikram, Mayur, and Manish for putting this together. Most of you know these guys, but these guys, Mahesh and Manish especially, work in the background. But none of this would have been possible without them. Especially, we'd also like to have your support. In these uncertain times due to COVID, we have not been able to have in-person meetups of lately, and it looks like we'll have to get used to some other platforms for the foreseeable future. So with that, we hope that you'll stay tuned. We hope that you'll continue giving us your support so that we can keep driving these events in an online platform. I'm personally excited because this would be the first webinar that we are doing for PUG. Mahesh might correct me if I'm wrong. And we are also planning to see if we can publish some of these to our YouTube channel so that they can be visited by people who are not able to attend the live ones. So let's see how that goes. Before I begin, my network provider has lost his backup power. So if there is a power cut in my area, I'm on a power backup, but my network might go down. But I will be back. I have a secondary network and it takes a while to switch, maybe a few seconds. If I do drop, Mahesh, please let me know. Even if I'm inaudible or if there's some background noise, we are getting used to this new form of content delivery. So let's make sure this experience is great for everyone. So coming to the webinar for today, the topic is easing up enterprise integrations with Azure Serverless. And it's very difficult to be someone who has not heard about the serverless buzz while working with cloud platforms. So we're going to quickly summarize the basics of serverless. But what we are going to do is we are going to look at the peculiar needs of enterprise scenarios and see how they map with Azure serverless offerings. We're going to get some overview of outstanding features that can help build a compliant solution. We'll also look at a problem statement and run through demos addressing some of the features uh, and try and understand them better. So we'll not be able to demonstrate everything, but we'll try to uh, demonstrate as much as possible aligned with a single problem statement. So we'll see what all of that is in the coming slides. Also, for those online, we have a hashtag PUG Live that's present over here. So if you're sending out a tweet or some social media post, make sure you have that hashtag. Just helps us understand what sort of reach we have. So a little bit about me. I'm Omkar Kher. I work at Rapid Circle. I'm currently helping build Leap DNA, which is a cloud governance platform for enterprises. I'm also part of the Intel Software Innovator program. I like tinkering around with IoT solutions. I'm also a technology enthusiast, so anything uh, that has lights on them, I like to play with those devices. So that's basically me. And I've been associated with PUG. I've been part of the community for almost a decade now. So yeah, that's basically me. So quickly starting with the topic for today, we're going to look at the evolution. So you can think of the evolution of man kind of a picture over here. Something similar is happening with serverless. So we started off with on-premise when we were building solutions. We started with on-premise solutions, and slowly the industry started getting more and more mature. There were service providers who came in with their servers, allowing you to offload your hardware headaches to someone else, to some expert who can manage your data center, and you could deploy your own services, applications, operating systems on this infrastructure. Then graduated into platform as a service. You have the Azure App Service. You don't have to worry about any IaaS configurations. You don't have to worry about low level configurations. Basically, you focus on your application and you deliver it to the platform and it's going to run. Serverless takes it a little bit ahead. Now, serverless again is a buzzword. It basically helps get people into the room, and most of the concepts have been around for quite some time. If you have used IFTTT, it has been around for quite some time. But certain usage patterns stood out, and the industry started noticing that hey, we could do something that actually addresses a very common problem over here. That being that, look, I don't even want to worry about any infrastructure and scaling aspects. Just let me deploy my code and let it run the way it's required. So that's where serverless comes into picture. It's sort of on the ahead of platform as a service. There's a lot of gray lines over here, so you can very easily start debates around which component becomes serverless, which component becomes PAS. I would recommend not to get in such arguments. As long as things are getting your work done, you should be good. Um, a quick overview. Well, 3 points that serverless tries to make. It tries to abstract away the server, basically. The name says it. You don't have to worry about the server component of your solution at all. You just look at the business logic, and you hide all the servers away. Uh, they also are event-driven scaling. Basically, you scale on very particular events. Uh, uh, it's also easy with the serverless approach because your business logic is combined into a single unit. So it's very easy to scale those units when a certain event occurs. Uh, then we have micro billing as well. So with micro billing, you're getting billed per execution, CPU and memory time being used, etc. Those who have already used functions would know this, the way functions are built or logic apps are built. But why are we doing all this? Well, manage business applications, not servers. That's the idea. Reduce operational overheads like DevOps, and get faster to the market. So that brings Microsoft into the picture. Microsoft has a tight grip on the cloud market. It won't shy away from such a common usage pattern. That's where Azure Serverless comes into picture. And these are just a few images. I'm sorry about the quality of the images over here. These was SVGs that were imported, but PowerPoint somehow tries to stretch things out there. It's weird. Uh, but basically, Microsoft has a good understanding of enterprise needs. And that's what Microsoft is doing with Azure Serverless as well. It's not just the toy that most people like to look at, like that. Okay, if there's a quick solution that you have to build, a POC, or a small patch that you want to have in your whole integration pipeline, serverless can help you. It can fit, especially Azure Serverless can fit very well in huge enterprise scenarios with the kind of niches they offer in terms of enterprise needs. But we are saying this a lot. So what are the special needs of an enterprise scenario? What are we really talking about over here? Well, the usual suspects are you need granular access control. You want it to be highly scalable. You want to make sure that scale is not becoming an issue at all. You want integration with private networks. You want broad range of integrations as well, including authentication mechanism, including integration with existing solutions. It could be a SAP solution, or even your own one of the broad range of ERP solutions that companies tend to have on board. So enterprises do look for these features a lot, and these can be blockers for adoption of serverless technology, especially because it's all very simplified. How do you get all of this done? So that's the point for today. But to make that point, what we'll do is we will look at a problem statement. So uh, here we go. So what we are going to do is we are going to work with this problem statement and try to see how some of the serverless components fit. Now, of course, we are not going to cover the full breadth of Azure serverless components. There's a lot of them. We are going to focus on 3 specific ones. If you have read the session description, you know exactly what I'm talking about. So here's the problem statement. Northwind traders wants to send out notifications to suppliers when they intend to raise RFPs, basically request for proposals, and vendors like Prosware would like to stay up to date with RFP events. So this is an integration across enterprises scenario, right? There's two enterprises over here. There's Northwind traders and there's Prosware, and Northwind is going to have some sort of a request that, hey, we want to buy XYZ, and who can provide that and who can provide the lowest cost or best quality, etc., etc. So there's an event that's going to be raised by an enterprise solution that's used by Northwind, and vendors. Well, one of the many would be Prosware, and they want to make sure that they are able to tap into these events and integrate them into their existing ERP solutions, maybe inform the sales teams, or so on. There could be a lot of other scenarios that Prosware wants to do by itself. So they have to be isolated as well. So we're basically trying to, as they say for enterprise integrations, it's you have to achieve that semantic unification of these two enterprises. So that's what we are going to try and achieve. And we're going to see what additional capabilities there are. We're not going to scope our understanding over here, but going to try and expand our boundaries a little bit along the resources that we pick up. So let's start brainstorming. So the first part, Northwind traders, outbound communication, that's the first piece. We want to notify vendors of new RFPs, ensure that vendors can control the subscriptions. Of course, it's up to them how they want to integrate into their systems. Northwind cannot dictate that. They want to make sure that the notifications are sent, and there's still a decent amount of flexibility there. And they want to isolate this notification structure. So how do we do that? And so what we are going to look at for the first phase of this problem is event grid. And by the way, the comments are on the Q&A section for this webinar is on. So if you have any questions, any comments, do feel free to post them. Vikram and Mahesh are helping me out over there to make sure we are able to pick those questions and address them. We might not be able to address all of those though, but do send in your comments. Um, I feel most of you who have worked with enterprise solutions would be aware of Event Grid. Before I even start talking about Event Grid, I always like to communicate this. There's a key difference. There's always this question, hey, Event Grid, but how's it different from Event Hub? And what about that service bus guy? So there's a key difference over there. One easy way to differentiate is there's events and there's messages. Events are basically where your system wants to just notify a network that, hey, XYZ has happened, an email has been received, or an RFP has been created, so on. That's an event. A message is contractually bound, wherein both participants, the sender and the receiver, have a deep understanding of what the structure of that message is going to be, what the model would look like for people who write code. So that's basically the key difference. That is what moves service bus out of our scope. Event hub, on the other hand, is designed specifically to process a lot of events, process a large volume of events, millions of events a second. That's the scale that it can offer. So it's not more for consumption, but it's more for processing. And here we're looking at a consumption based model. So we're going to look at event grid. So what it allows you to do is it allows you to manage events that trigger logical components. Basically, you can, if there is a mail sent out and you want to notify a system that an X email was sent, do log this that we have sent an email. You can do that. The systems can scale. A publisher does not need to know who the subscribers really are. The subscribers just come into picture. That is what fits this model as well. Deeply integrated with Azure resources, that's a plus. Maybe not for the problem statement that we are looking at, but if you are building a solution that, especially a microservices or a solution that is like microservices, you would want to use something like Event Grid to make sure all your services are able to pump in events. So that other services can subscribe and make sure that they are in loop of what's happening, and they can react to those events that other services are creating. So if, say, you have a photo upload service that's completely isolated from your actual messenger service, So you want to generate an event that, hey, a photo has been uploaded, so the messenger knows that it has to refresh the URL for a user on the interface, so that the right display picture, the new display picture can be made visible. Uh, Topic and subscription model. Most of you would be aware of that. You basically declare topics that mention email could be a topic, and all notifications regarding email go over there. Or photo can be a topic, and new uploads, modifications, all of those can go on those topics. And then there can be subscribers to those topics. There can be further filters as well, but we'll look at that. Event Grid also offers partner topics. This is something new. This is something that Microsoft has recently started work on, and I believe Auth0 is one of the partner topics that has come on board. So what it allows you to do is there can be partners in the Event Grid ecosystem that that can publish events. So if you are using Auth0, you can actually have a topic dedicated for Auth0, where Auth0 as a third-party service will pump in events into your event grid whenever there is a login or whenever there's a Auth0 event happening. So that's an interesting one as well. You can also register as a partner. I've not explored what the process over there is, but if you're interested in something like that, do look at it. Then this event grid domain. Now this is going to be interesting because the regular event grid offering is focused around Azure events as well. You can have custom events, but there isn't strong scoping over there. What event grid domain does it allows you to apply the domain driven design to your solution. So let's take a look at event grid domain. So you want to manage, you are able to manage access over here per topic. So you can have a topic and make sure that certain users have access only to a topic and they can manage subscriptions within that topic. You have a single endpoint for all events. So those who have worked with Event Grid would know that the Event Grid endpoint where you publish events, where your application would publish an event, has the topic in the URL. What Event Grid domain does is it provides you a single URL where all your events can be pumped in. And this makes a huge difference when you're building an integration, especially. This might not look like a very big difference from what I'm saying, but when you're implementing it, it makes a huge difference because now you can use a single URL to send events across multiple topics. So you can batch events across multiple topics together, and we're going to look at an example of that in a few seconds. It also allows you to do domain driven design, so that's already covered, and the model looks something like this. So you have the whole event grid domain, and you have a single endpoint where so this is Contoso, but you replace this by Northwind, and this is where Northwind can start sending its events to different topics. And every organization, every vendor in the Northwind ecosystem can have their own dedicated topic and start managing their own event subscriptions that connect with their own enterprise solutions. So it's as easy as that. What you're going to do is we're going to quickly look at Northwind traders. So what I've done on Azure is I have created this resource for Northwind traders already. I didn't want to spend time creating resources in this session in interest of time. So I already have an event grid domain that's created. And you can see that early today I ran one test. So we are going to integrate with Prosware, right? So there's already a topic created as well. So what you can do is I'll show you what the flow looks like. So you can create a subscription over here, and that particular you can have a topic. I already have a Prosware topic. You can create your own fresh topic. You can have your own event types, basically a filter across the types of events that would like to be that would be provided to these subscriptions, so that not all events on this topic are sent. You can just filter things out to what's important. And you can further integrate, you can send these notifications to either Azure Functions. So this is deep integration with Azure. So if you select Azure Functions, you're going to see a list of functions over here that you can integrate with. So I don't have anything in this resource group, but maybe I have something over here. Nope. Okay, I think, yeah. So you see, I have some other applications. You see those function apps over here. I can start sending notifications to them directly. What we are going to do over here is we can also select webhooks. This scenario, especially, it's across multiple enterprises. So it's not going to be possible to utilize the deep integration where you look at Azure function. You're not going to see the Azure functions from someone else's Azure tenant. Webhooks makes it easy. So we're going to select a webhook and we're going to create a subscription. Something like this has already been created. So what we have over here is, yeah. So this is one subscription that we have created that has a webhook. So we're going to go into the details of this a bit later. But this is what's possible with event grid domains. So you can have the best part, a big difference that you notice is the normal event grid does not have this access control link over here. So I can go here and under role assignments, I can see this event grid event subscription contributor. So this user is a guest user and can make sure and can start managing event subscriptions. Now, what's interesting to note is this particular role is not visible in this list yet. But you can do this through PowerShell. So that's what I have done. Through PowerShell, you can add a guest user. So you can say that you can add a Prosware user as an event grid event subscription contributor so that they can make sure that they can manage the event subscriptions over here. So for every organization, you can do that per topic. Every organization has their own topic. And for every organization topic, you can have a guest user who has manager rights or an identity from their Active Directory who can manage the subscriptions over here. So that's how you're lending out control. Yeah. So we are going to quickly look at the limits of event grid. So you basically have 100,000 topics per event domain, 100 events per Azure subscription, blah blah blah. So this is something that you can easily find in the documentation as well. And most of these limits are pretty difficult and pretty challenging to reach. But if you do, you'll have to make some decent architectural decisions to make sure you're functioning well. So you want to go to the next phase. So this solves the event grid domain solves the problem for from the Northwind front that okay, as Northwind, they can create an event grid domain, they can add a Prosware user, done, their problem is solved. So they can start pumping in RFP events into that event grid and make sure that all topics are getting events that would be relevant to them. What I'm going to do is something that I can right away. Yeah. So actually, I have this is Insomnia, a similar client like Postman, where you can send REST requests. So this is the same event grid that we have created. So this is something that I wanted to show as well. This is the common URL that's used for this event grid domain. So this is the same URL as the domain endpoint. And this single domain endpoint can be used to send events across multiple topics. So you'll notice that there is a topic property here, which is not present in the event grid schema for a normal event grid. The topic is over here because you can have multiple such events, so you can create an array of such events and send these to multiple topics. So I can say Contoso is going to join this as well. And it's an identical event, so it's the same RFP event I'm creating. And I can send it out, and that's basically going to give me an okay. And the event grid, if there are any subscriptions, it's going to get delivered. That's the way it basically functions. What we have also done is, as Northwind, the event cannot have the full RFP, right? So what we have done is we have stored the RFP as an XML file in a storage account. So this is something that I was missing. So what we have done is we have hosted this XML file over here, which has the details of the RFP. It's a publicly accessible URL. So if I go here, I'm able to, whoops. Yeah, I'm able to see that XML. We're going to look at the structure of that XML and everything a bit later. But that's basically what we have done. So the idea is that you're just sending out a notification saying that, hey, an event is created, an RFP is created, This event indicates creation of a new RFP, and it includes the metadata that's required to consume that RFP. So here's the URL for the RFP. You would of course authenticate, have some authentication mechanisms around this. So Northwind can have its own authentication mechanism that Prosware or Contoso would have to respect and make sure this file gets downloaded into their systems and get included in their internal company workflows. So coming to the next part, so there's the Prosware Northwind integration. So Prosware would like to register a webhook to receive notifications from Northwind. Prosware would like to store the RFP to allow access to multiple businesses within the organization. So what they want to do is, now we have the URL. We know that an event is going to get triggered. And once that event is triggered, the event is going to include a URL to the RFP. We want to listen to that event. And further, we want to download that RFP and store it in a location that can be accessed by other businesses within Prosware, whoever would find it relevant, mostly the sales team in our case. So we are going to look at functions over here. Most of you are well aware of what functions are capable of, so I'm not going to go into too much detail over here. We're going to look at the code and everything, but quick overview. Uh, you can basically execute code based on specific events. So functions have this concept of input and output bindings, and they basically allow you to have inputs. There can be triggers, there can be certain events like a blob storage event, or an event grid is even supported. There can be an HTTP request. There's a wide range, and so these events can basically trigger off the code that you have written for a function. That's basically the business logic, and that's basically it. And it is able to scale based on the way events are occurring. So you don't really have to manage the scale units the way you would normally do in case of app services. In our case, it would not make sense to go for an app service just for a single webhook. There's a lot of operational hassle that we are basically subscribing to. So instead of that, we build a simple function, and that should work for us. Uh, Event grid is supported, but we might not be able to use that because the event grid is not going to be in our same as your tenant. So that deep integration is not going to work. So we are going to still go for, we are looking for a webhook subscription. So we are going to go for the HTTP request, but we are going to use blob storage to actually store the RFP. So functions does support custom Docker containers as well. That's just part of the features. And when you're talking about scale, you have the consumption based model, which is the most popular one, being that gets that gets chosen, because you basically don't have to have any app service plan, anything attached to it. You just create a function, and it just starts getting triggered as per the events that are coming in. Uh, but in some cases, you would want to have more control over the way your functions are operating. You might want to have virtual network integrations, in which case app service plans make sense. You can have a function residing in an app service plan along with other app services, so that it's consuming maybe if you have some excess compute and memory available in your app service plan, you're not fully utilizing it. It would be a good decision to maybe put a function in the app service plan, and the app service plan also allows you to integrate with a virtual network. So if the blob storage account is a part of a virtual network as well, you are very easily able to access it. Another approach is app service environment, which basically is the same as you use for an app service. It's basically like a private data center hosted inside Azure for you. It's dedicated hardware. It's making sure that you are not on any shared infrastructure. It's basically a step ahead and a step forward in terms of security. There's of course VNet integrations over there as well. KEDA, I just added, so I forgot to update the count over there. It still says 3 forms. So KEDA is basically, they've retired Azure Functions runtime, and KEDA is the approach that they're taking using Kubernetes. You can actually orchestrate functions within your VMs as well. So that's something, if you're interested in, if you would like to prefer to not get vendor locked, KEDA would be the approach to take, where you have your own virtual machines. You can have the functions get orchestrated over there. So yeah, that's basically it. we are going to quickly take a look at what we are doing with functions in our solution now. So I'm going to open so I've built a function over here, and we're going to quickly take a look at the code. So what I've done is we have I've, we are using the event grid models. So because this is going to be an HTTP endpoint that is going to be exposed uh, for event grid, so all the events that are going to come in are going to comply with the event grid schema. We have just used the same models over here. It's going to be a list of events that are going to come our way, and we are going to use the blob container to store the RFP XML file. So what we are going to do is we're going to log quickly how many events are received. Further, we are looping through all the events that we have received and check if the so this is an interesting part. So when you register for a webhook, so if you remember the form over here, so if I select webhook over here in this form, and I provide an endpoint, provide our functions endpoint over here, uh, Azure is going to try and verify if this webhook really is owned by you, so that you're not basically sending out requests to someone else's URL. To make sure that you actually own that endpoint, uh, Azure is going to send you a validation URL over here. There's two validation mechanisms used. You can automate this as well, or you can use the validation URL and you can click it manually. So you first register the webhook, you'll get an event which is of event type Microsoft Event Grid subscription validation event. Uh, when you receive this event, you'll have a validation URL. If you open that validation URL either through function or within your browser, it's going to approve that webhook. So that's a step necessary. That's something that we have handled over here. Uh, in next, what we are going to do is we are going to get the RFP package over here. So we have created a RFP descriptor. So it is complying with the same model, the ID and XML that we are sending as part of our event. So we are making sure we are getting the ID and we are getting the XML URL. We're going to we are going to parse that. We're going to generate a blob name. We're going to keep the descriptor ID as the name of the XML file. And next, what we are going to do is upload that file into blob storage. That's basically it. That is what we are going to do. And we have already published this. So what we can do is we can go to Prosware. You can see that I've deployed a function app with an app service plan. Idea being if there is a VNet integration done to the storage account, we can make sure that it can be accessed by the function. And under functions, you're able to see that the RFP notification is present. So what we'll do is we will, considering that the webhook is already registered, we'll go to monitor and go to logs. Yeah. And considering that the webhook is registered, what's going to happen is we are sending this event to the event grid. The prosware event and only the prosware event would be sent to the webhook because that is the scope of our subscription. We are subscribed to the prosware topic. It should download this file and store it in this account. That's our prosware. So let us quickly trigger this. Actually, I've done this before, so let me actually change the file name, file number from 11 to 12. So this is a new event now, so that we're able to see a new file because it's basically going to write over an existing file. So you see, there's two events that were fired because the first one with ending with 11 and the second one ending with 12. So they are being triggered. What we're going to do is we're going to look at the broker store and we're going to go to Northwind RFP. So you see over here, these are the two files, timestamp matches 11.5. So about a few seconds ago at 11:04, these two files were created. The RFP is basically downloaded over here. So great, that's an XML file that we have in our store. So what we can say with this is uh, pretty easily we are able to satisfy this condition where Prosware is able to register to a webhook, receive notifications, and store the RFP file within a storage account that can be accessed by multiple businesses within Prosware. So moving next to the final phase. In the final phase, what we are looking at is the sales team at Prosware would like to receive an email notification with details from the RFP. So this is where things start getting a bit interesting. Um, we're going to start looking at logic apps then, because this is something that the sales team can easily manage. They would like to have uh, uh, they would like to design workflows. Basically, logic app allows you to allows you to design a workflow from on a UI. So it's basically designed to keep designed keeping the citizen developer in mind. It has an intuitive UI with a marketplace of application connectors. You can build your own custom connectors as well with Logic Apps. Nothing stops you from doing that. And for developers, especially a JSON-based declarative schema can be used to write a Logic app. So if you want to do some sort of source control, you can still do that because there's a JSON schema where you can make sure that you can replicate Logic apps in multiple locations if you have to do that. Because if it's just a UI-based thing, then it can be a very tedious job to do. So we want to take a look at Logic Apps, but we are looking at enterprise scenarios. So how does Logic App fit in this enterprise scenario? So if you want to integrate with VNets, Logic Apps does offer integration service environments for VNet and that support isolated infrastructure. This is very much in line with the app service environments. Integration service environments are just tailored for logic apps. They work, the isolation part and the network integration parts work very similar. They also logic apps also support integration accounts, so you can have mappings, you can have assemblies. We'll take a look at these on the Azure portal. And there's also support for a wide range of enterprise integration standards, which basically makes logic apps a very powerful contender over here. So let's take a look at first. Let's take a look at the integration service environment. So what I've done is today at 7:30 I deployed an integration service environment. It takes some time, can take between 1.5 hours to 2 hours to deploy. So I'm quickly going to go to this resource. And it's going to be empty. We have nothing over here, but we get to see this is a developer SKU, so it's cheaper. These services cost a bomb, by the way. So this is going to I'm getting charged $1, a little more than $1 per hour right now. And if I go for a premium SKU, it would be a little above $6 per hour. But in case of an enterprise scenario, the benefits that these services offer usually outweigh the costs that get incurred. So you see that you can list logic apps over here. You can list an integration account over here. You can list API connections. It basically gives you a single place to manage all of the resources that would function together. What I've done for simplicity is, and if we get time, we'll try to build a logic app over here as well. But for the sake of simplicity, I have created a logic app, Prosware sales dashboard as well. What we have done over here is we have created a logic app that listens, which most of you would have guessed already, listens to a blob trigger. So what we are doing is we are listening, we have connected this logic app to trigger in such a way that when a blob is created in the Northwind RFP collection container, uh, we are notified. It triggers this workflow basically. And right next was something to note over here is these do not work for directories. So if you're uploading to a storage account container and you're having a directory in here, that blob is not going to trigger an event. So that's something that's important to note. I found this out last weekend, and I had originally planned to create directories, which didn't work out well for me. You can then get the blob content. So this is going to be properties only. It says properties only. So it's going to get the blob properties, and using those properties, you can get the path of the file where the blob was created. So that's going to be the new RFP that was created. And once the new RFP content is received, we want to derive information and send an email. Right now, we said that it's an XML file. So let's take a look at what that XML file looks like. Okay, is this visible? Can someone, Mahesh, is this visible enough, or do I need to zoom in? Okay, I'm going to assume this is visible. Okay. Okay, so our RFP looks something like this. It's an XML file. It has a title. The intention is to create the largest Lego Death Star. That's what Northwind wants to do. There is an ID over here. There's a type over here, and there's a list of orders over here that has name. What all do you need to build the largest Lego Death Star? You'll need a Darth Vader. Death Star is not complete without one. You need a few stormtroopers, royal guards, square blocks, blasters, blah blah blah. Note vendor has to take care of shipping and other logistics. There's a note added over here. So we want to parse this XML and put it out in an email. And people who have worked with Flow, especially, or even Logic apps, some of you might also guess that we can do a lot of placeholders while sending an email. Something like that might work out, but it gets pretty tricky and pretty messy quickly. So what Logic App offers is you can utilize an integration account. So what we have done is under workflow settings, you can see that I have associated an integration account over here, and we're going to take a look at that integration account right away. Under maps, you can basically have maps that are defined in different formats. There's XSLT support. We're using Liquid today, and we're going to take a look at the Liquid template that we have used. So let's take a look. I have the XML over here as well, just to make sure that you have good context of what we are doing. So here's the email that I've created using Liquid, and we're basically saying, "Hello team, Northwind has received a notification Northwind has issued a notification requesting proposals against the following order," and you want to have the order over here. So these are just simple placeholders that we can add to this Liquid file. We're saying content.title goes in the right place, content.id, we add the type as well. The order details is going to be a for loop. So you have for loop. This looks a lot like a templating language for who have used JavaScript frameworks like Handlebar, etc. They have very similar protocols as well. So you can loop across content orders, then you can have order name and quantity being mentioned over here and a note over here. So what we have done is we have uploaded exactly this map as an RFP map. And in our Logic app, we are using the same map to parse the file content and generate a blob of text. That's it. So in the end, what we are doing is we are getting the transformed content and sending it out over an email. So I created a fresh email account yesterday. I thought that maybe for a demo, it would be good to start with a fresh email account, which I've created, and you might see it open already. And there's a few notifications over there. So this is because we have been running the event tests already. I'm going to quickly archive this, and just for the sake of demo, we are going to trigger this flow again. It takes a little more than a minute, or sometimes just about a minute for it to trigger. So it's going to send in a fresh email over here. If not, we'll take a look at the archive. So that's basically how you do this end to end in a Logic app. So by until that email gets delivered, I'm going to quickly show you the whole picture, what it looks like right now. So basically, the Northwind staff can have a working on a Northwind ERP can publish an RFP over there. That RFP event can be sent to event grid. The integration is pretty simple. We are looking at a REST API over here. This is a REST API that has to go through. So we are not got that into this demo. As long as the event hub domain has the event received, it can start sending out notifications to webhooks. On the Prosware side, we have a function that is being used to host that webhook, which goes ahead and stores the RFP, goes and downloads the RFP and stores the RFP on a blob storage that can be accessed by businesses at Prosware. So once that's done, different businesses can start listening to events on the blob storage that whenever a new RFP arrives over there, let us know and they'll create their own flows. The sales team very creatively created their own flow using a Logic app, and that gets sent, let's say it was Prosware sales distribution list where the team can receive emails that look something. Yeah, there we have something like this. So we have this nice, pretty looking email which says Northwind has issued this and there's the intent to create the largest Lego Death Star. We have the order details: Darth Vader 1, Stormtroopers 60, Royal Guards 20, Square Blocks, Blasters. Yeah. So do we have any questions? Mahesh, Vikram, do we have any pending questions? If not, looks like I've been crystal clear throughout the session, which is a good sign in a way. Okay. Looks like there aren't any questions. Looks like we do have. I've actually finished 10 minutes, a little more than 10 minutes before time. So if you have any specific questions, we actually have some good time right now to discuss. Let me quickly check if okay, I'm going to just move to the next slide until then for the summary. So Mahesh, if you're speaking, I'm not able to hear you because you're on mute.
No, I'm not speaking.
Okay, cool, cool. Okay, so I'm assuming there are no questions right now, right? So we'll move towards the conclusion of the session. Okay. So in summary, we basically looked at event grid, function, and logic apps. I like to address them as the three gems of the Azure serverless offering because these tend to get the most done. There's a lot more. You can also consider storage account as one of them, Cosmos DB or API management services. They have their own, they solve very niche problems. Uh, but these three usually end up being used in most scenarios. So I hope you liked the session. I hope this information was useful to you. I will be aggregating this information into a blog and publishing it with the sample code in a Git repository as well. That would be available on my blog. So the link is over here.
Omkar, we have one question here.
Okay, that's good.
What is liquid?
Oh, okay. So let me go at the liquid file again. That helps. So liquid is basically it's something that I believe Shopify has standardized, and it works very similar to an XSLT, where XSLT allows you to transform data from an XML schema to another XML schema. With liquid, oops, sorry. With Liquid, you are able to transform data between XML to JSON, JSON to XML, and XML to text or JSON to text. So it's pretty powerful at transforming data, and it can do a lot of complex tasks. So I can actually quickly open up Yeah, so that's where you can look at the liquid documentation. There's a bunch of operators that they have introduced. There's logical operators. You can do equating as well. You can do filtering. You can basically escape data as well if you want to do some serious parsing of text. So there's a lot of interesting stuff that you can do. You can do some mathematical operations. In terms of data transformation, liquid tends to be pretty powerful then. And yeah, that's basically it. It's basically a standard for transformation. I hope that answers that question. Maybe we wait for another minute if there are any more questions, or else we can conclude today's session.
Yes, we have one more.
Okay, does this handle parallel execution? If there's 1000 triggers at the same time, then how can function trigger? Yes, of course they are concurrent, and functions. The function infrastructure provides you the ability to configure how this execution occurs, how the concurrency occurs as well. So you can write functions in PowerShell as well. You can write functions in a lot of languages: C Sharp, JavaScript, C Sharp script as well. If you're using the Azure Portal editor, um, so for each of these languages, there can be specific configurations. For instance, in case of PowerShell, you can decide how the processes are shared. If you want to run multiple instances along a shared process, or would you prefer to have a single process, so on. But it does handle concurrency. So if there are multiple events, you're not going to have bottlenecks where it says that there's one execution happening and let it finish, and then the next one gets picked up. That's not the case. Concurrency is covered for. What you do need to keep in mind is getting your functions pre-warmed. So uh, when the functions have worked similar to an app service. If you have worked with an app service, especially in the free tier, and it's not the first hit that you make takes 30 seconds to basically get a response, because your whole code is getting bootstrapped over there. So if you need pre-warmed instances, you want to consider either the premium tiers, or want to move to an app service environment where your function are always pre-warmed, and make sure that any hit you are basically able to deliver a response within a few milliseconds, assuming you're not doing any other blocking IO. Do we have anything else? Okay,
Yes.
there's a couple more. Okay. Um, okay, I see the same question again. I think, okay, there's a new one. That's Utkarsh. This is regarding function app. How can we share some code across function app? Suppose I have two function app and both require some common functionality module. Right now, a way is to duplicate code or using npm modules in case of Node. So in case of C Sharp as well, you can have shared class libraries. Now, again, when you're saying multiple functions apps, let me be clear. In a function, you can have multiple triggers. So nothing stops you from having multiple triggers in the same function app. Let me go back to a function app. So you can have multiple functions residing over here. This is not going to be the only one. So that's one way. If you think the problem domain, they all fit in the same problem domain, you can plug them up together. But there can be cases where you have multiple function app, you want to have them across different applications, but still share code. In case of C Sharp, it's pretty easy. Again, you can have class libraries that are shared. You basically use the implement services that can be used by these functions. And at compile time, they're basically making sure they are getting the right dependencies and running. So that's one way. This does give me, I think I can highlight another point that might run parallel to this as well. when you're creating a function app, especially HTTP triggers, and you might want to implement an API that uh, 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 arrest API on these HTTP triggers, and the signature of these APIs is not going to look very pretty because they're all functions. So you can start using function proxies to make sure all your function triggers are brought under a single umbrella, and you can have them exposed on a single surface as opposed to multiple functions spread across everywhere. You can have them all exposed on a single surface using function proxies. So yeah, that's basically about sharing common code or creating a common surface to access those functions.
There is one more for.
Okay, I think it takes a couple seconds for me to see these questions once they're published. Let me look at. Okay, I can see the new ones as well over here. That makes it easy for me.
Yeah.
Okay. Also, can I expose an API from a function? Can use same function for event-based trigger. Can I expose an API from a function? Can use same function? Yes, of course you can do that. So what I sense is what you're intending to ask is that can you create an API function, which is basically an HTTP API, and trigger an event within that API? That's certainly possible. You can do that. So I hope that that answers your question. So there's no even in our example, what we have done is it's an HTTP API. But we are creating a blob out of that out of that function itself. So there's nothing stopping you from doing that. Even if there's some blocker, you can basically write C# code to make HTTP calls. So that just works. Okay, looks like no new questions. Mahesh, do we conclude the session then?
Yes, we can.
Great. Thank you once again, everyone, for attending, and thank you, Mahesh, Vikram, for helping me out here. I think this was a good session, and there'll be announced. Mahesh, maybe you can give an update about future webinars that will be scheduled.
Yes. We have another the second session in this series on next Saturday. We planning to have a couple of sessions in the same similar webinar on coming Saturdays. Either each Saturday or at least alternate Saturday, we're going to have the speakers from the community, the MVP community, and Microsoft as well. So keep following up us on Twitter, Facebook, and Meetup. You will get an update there. All these going to be a live webinar unless we all come out of this COVID situation. We will be connecting live every Saturday or at least alternate Saturday. And also if you want to participate in the that is conduct the webinar, please contact me on my email ID. Or you can also ping us on Twitter or Facebook. We will get in touch with you and we can schedule similar session for you. Thanks, Omkar, for kick off this POG live series. And thanks, Vikram Manish, for all the help. Thank you. Let's conclude here.
Thanks, everyone. Bye-bye.